Hello, my dear children. In the previous class, we have discussed what is meant by a polynomial, which algebraic expressions are called polynomials. Next, what are the terms of a polynomial, and what is the coefficients of terms of a polynomial, what is meant by zero polynomial, what is meant by degree of a polynomial, how to find degree of a polynomial. We have discussed all these points. The classification of polynomials based on the number of terms and also the degree of the polynomial. We have discussed all these points and we have solved the problems in exercise 2.1. Now come to the exercise 2.2. Exercise 2.2. In this exercise, we discuss these 6 points. The first point, these 6 concepts we discuss in this exercise. You have to learn well. Are you ready to learn these points well, my dear children? Right. First point, the first concept is zero of a polynomial. We discuss what is meant by zero of a polynomial. And the second one, root of the polynomial equation. What is meant by root of the polynomial equation? And the third point, zero of a non-zero constant polynomial. What is the zero of a non-zero constant polynomial? And the fourth point, zero of the zero polynomial. What is the zero of the zero polynomial? And the fifth one, finding a zero of a polynomial. If a polynomial is given, how to find zero of the polynomial? We discuss in this point. And the sixth one, some observations. By discussing all these 5 points, we get some observation. We observe some points. We discuss that points also here. Okay, my dear children? Right. Now come to the first point. Before to this point, in general, throughout this chapter, polynomials, P of x, Q of x, R of x, these are the notations to denote a polynomial. In general, we use these notations to denote a polynomial in x. Okay, my dear children, throughout this chapter, P of x denotes a polynomial in x. Similarly, Q of x is also a polynomial in x. R of x is also a polynomial in x. Remember these points, my dear children, throughout this chapter. Now, come to the first point. What is, what is the first point? Zero of a polynomial. What is meant by zero of a polynomial? Suppose P of x is a polynomial. Previously I told you, P of x denotes a polynomial in x. And C is some number. It may be 1, it may be 2, it may be -5, it may be 2 by 3. It is some number. If P of C is equal to 0, this sentence means if you substitute in this polynomial, if you substitute x is equal to c, if you substitute x is equal to c in the given polynomial, and after simplification, after calculation, finally we get 0, then the number c is called 0 of the polynomial P of x. Understood this point, my dear children? Here P of x is a polynomial in x and c is some number. They will give some number. Don't worry about it. They will give polynomial in x and they will give some number. Okay, my dear children. Now we have to check whether the number is a 0 of the polynomial or not. To check whether the given number is a polynomial, 0 of the polynomial or not, we have to substitute x is equal to c. We have to put x is equal to c in the given polynomial. Understood, my children? First step is we have to substitute x is equal to c in the given polynomial. And second step is we have to simplify. We have to calculate the value of the polynomial. If you get 0, finally if you get 0, then the given number c is said to be 0 of the polynomial. Understood this point, my dear children? To understand this point well, let us take an example. Let p of x is equal to minus x square plus 5x minus 6. This is a polynomial in x. It is given like this, p of x is equal to, and c is equal to 2. They have given some number 2. Now let us check whether this number 2 is a 0 of the polynomial or not. Then what I said, we have to substitute c is equal to 2 in the polynomial. We have to put x is equal to 2. We have to substitute this value in the polynomial in the place of x. So p of c, that is p of 2 here. We are finding p of 2 value. We are finding here p of 2 value. So minus x means here we are substituting 2. So 2 square plus 5x means 5 into 2 minus 6. In the first step we substituted x is equal to 2 in the polynomial. Then what will you get here? Minus 2 square, 4, plus 5 into 2. What will you get here? 10 minus 6. Understood this step, my dear children? Right. Now I wrote here plus 10 minus 4 minus 6. What will you get? Minus 10. Understood this step, my dear children? 10 minus 10. What will you get here? 0. Finally, what you got here? 0. After substituting the number in the given polynomial in the place of x, we got 0. Therefore, the number 2, what is the number substituted in the polynomial in the place of x? 2. So, this number 2 is 0 of the polynomial p of x. Understood this point, my dear children? Right. Now, let us take another example. I have taken the same polynomial p of x is equal to minus x square plus 5x minus 6. I have taken the same polynomial, but here I changed the number 1. In the previous example I have taken number 2, but here I have taken number 1. Now let us check this number 1 is a 0 of the polynomial or not. What are the steps to be followed? We have to substitute x is equal to 1 in this polynomial. What is the given number here? 1. So we have to substitute 1 in the place of x in the given polynomial. Then what will you get here? P of 1. P of 1 is equal to minus 1 whole square plus 5 into 1 minus 6. In this first step, what I did here, just I substituted. I replaced x by 1. Understood this step, my dear children? Right. Now the next step is simplification. We have to simplify these 3 terms. Understood, my dear children? Right. That is equal to minus, what will you get? 1 square means 1 plus 5 into 1. What will you get here? 5 minus 6. Now, understood this step, my dear children? Right. Now we have to simplify these 3 terms. So first I wrote 5. Negative numbers, minus 1, minus 6. What will you get here? Minus 7. Okay, my dear children? Understood this step, my dear children? Is it clear? Right. 5 minus 7. Small number minus a big number. What will you get? Negative number, minus 2. Finally, what you got here? Minus 2. Is it a 0? It is a non-zero number. It is a non-zero number. It may be a positive number. It may be a negative number. It is not a matter. But it is not 0. Therefore, 1. What is the number we substitute in the polynomial? 1. So, 1 is not a 0 of the polynomial p of x. Understood, my dear children? Right. In the first point, we have discussed 0 of a polynomial. Okay, my dear children? Now come to the second point, second concept, root of the polynomial equation. It is linked with the first point. It is a continuation of the first point. Okay, my dear children? So here, to understand this concept well, to understand this concept clearly, let us take the same polynomial what I have taken in the previous examples. I have taken the same polynomial p of x is equal to minus x square plus 5x minus 6. For this polynomial, we have proved that 2 is a 0 of the polynomial. Isn't it or not, my dear children? We have proved or not? Yes. 2 is a 0 of the polynomial. Okay, my dear children. Now, if you write this equation, p of x is equal to 0, this is called polynomial equation because e is equal to sign is there. E is equal to. That is why this mathematical statement is called polynomial equation. What we call this mathematical statement? Polynomial equation, because e is equal to sign is there. So this mathematical equation is called a polynomial equation. This implies what is p of x here? Minus x square plus 5x minus 6. So in this equation, you know there are two parts, LHS and RHS. In LHS, I am writing the polynomial as it is, minus x square plus 5x minus 6 is equal to, in RHS what is there? 0. Then we get a polynomial equation like this. Okay, my dear children. Then here 2 is called the root of the polynomial equation p of x is equal to 0 because 2 is a 0 of the polynomial. If any constant is 0 of the given polynomial, if any constant is a 0 of the given polynomial, then the constant is said to be the root of the polynomial equation p of x is equal to 0. Understood, my dear children? Understood this concept clearly, my dear children? Right. Now come to the next part. Next part. We have proved that 1 is not a 0 of the polynomial p of x. In the previous example, we have proved that 1 is not a 0 of the polynomial p of x. For the same polynomial, it is not a 0. 1 is not a 0 of the polynomial p of x. Then we say that 1 is not a root of the polynomial equation p of x is equal to 0. Therefore, we say that 1 is not a root of the polynomial equation p of x is equal to 0. Understood, my dear children? I told you clearly, if any constant is a 0 of the polynomial, if any constant is a 0 of the polynomial, then the constant is said to be, a root of the polynomial equation p of x is equal to 0. I repeat the point, my dear children, listen carefully. If any constant is a 0 of the polynomial p of x, if any constant is a 0 of the polynomial p of x, then the constant is said to be, a root of the polynomial equation p of x is equal to 0. Understood this point, my dear children? Right. Now come to the next point, my dear children. That is third point. 0 of a non-zero constant polynomial. Then what about 0 of a non-zero constant polynomial? In fact, A non-zero constant polynomial has no zero. It means we can't find zero of a non-zero constant polynomial. Is it clear, my dear children? For example, p of x is equal to minus 3 by 2. Suppose a polynomial is given like this. Then what kind of polynomial this one? Non-zero constant polynomial. There is no x term, only constant term. That too a non-zero constant. Okay, my dear children. Then we say that it has no zero. We can't find zero of this non-zero constant polynomial because it is a non-zero constant polynomial. We can't find zero of a non-zero constant polynomial. Remember this point, my dear children. Understood? Right. In the last point, that is in the third point, we have discussed zero of a non-zero constant polynomial. Then a question arises. Then what about zero of the zero polynomial? What about zero of the zero polynomial? By convention, every real number is said to be zero of the zero polynomial. Every real number is said to be zero of the zero polynomial. We can take any real number. Any real number is a zero of the zero polynomial. For example, p of x is equal to 0. Don't confuse here, my dear children. This is not polynomial equation. This is given polynomial 0. Only one term, that too 0. Understood, my dear children? Then 2, minus 3 by 5, minus 1 by 6, etc. Any real number is said to be zeros of the given zero polynomial. Is it clear, my dear children? Right. Now come to the next point. That is fifth point, my dear children. We have discussed 4 points. Now come to the fifth point. Finding zero of the polynomial p of x. How to find? In this point, we discuss how to find zero of a given polynomial p of x. Okay, my dear children. In problems, they will give a polynomial in x, that is p of x. They will give a polynomial in x like this, p of x. To find zero of the given polynomial p of x, step 1, write the polynomial equation p of x is equal to 0. Means we have to write the given polynomial is equal to 0. They don't give this polynomial equation. We have to write this polynomial equation. They will give only a polynomial, but we have to write this polynomial equation. Understood step 1, my dear children? Right. Now come to step 2. Here we got a polynomial equation. We have to solve the polynomial equation. We have to solve this equation. Then we get some values for x. Isn't it or not, my dear children? We get some values for x. Step 3. The value of x, whatever the values we got after solving the polynomial equation, the values of x is said to be 0 of the polynomial p of x. Follow these 3 steps, my dear children, in finding 0 of the given polynomial p of x. Is it clear, my dear children? Let us take one example how to find 0 of a given polynomial p of x. Okay, my dear children? Right. Now let us take an example for finding the 0 of a polynomial p of x. See here, find 0 of the polynomial p of x is equal to 7x minus 2. This is the given polynomial. We have to find 0 of this polynomial. come to the solution part. First we write the given polynomial. What is the given polynomial here? P of x is equal to 7x minus 2. I wrote this given polynomial. Understood, my dear children? Right. We are going to find 0 of this polynomial. Then what is the first step? We have to write a polynomial equation P of x is equal to 0. So let us write polynomial equation P of x is equal to 0. This is a polynomial equation. This implies in LHS P of x is there. What is P of x? 7x minus 2. Write that polynomial in LHS is equal to 0. Understood this step, my dear children? Right. Now we have to solve this equation. Step 2, I told you. Step 2, we have to solve the polynomial equation. So here this is x term and this is a constant term. So first we send the constant term to RHS. Then it becomes plus 2. So 7x is equal to 0 plus 2. Understood this step, my dear children? Right. This implies 7x is equal to 0 plus 2. What will you get here? 2 only. Okay, my dear children. Now we send this 7 to RHS. This implies we write LHS x only. In LHS only x will be left there, is equal to 2 by 7, because here it is multiplying with this x. 7 is multiplied by x. So it becomes here by divided by 7. So x is equal to 2 by 7. This is the value of x we got after solving the polynomial equation P of x is equal to 0. Therefore, this number, this real number 2 by 7 is said to be 0 of the given polynomial P of x. Is it clear, my dear children? Understood how to find 0 of the given polynomial P of x? Right. Now come to the last point, that is observations. These are the some points we observed. That is the first point. A 0 of a polynomial need not be 0. 0 of a polynomial need not be 0. It may be any real number. And second point, 0 may be a 0 of a polynomial. This is also one point. Observation, one observation. And the third point, every linear polynomial has one and only one 0. Every linear polynomial has one and only one 0. And fourth point, a polynomial can have more than one 0. For example, 2 and 3 are the zeros of the polynomial P of x is equal to x square minus 5x plus 6. Because P of 2 is equal to 0 and P of 3 is equal to 0. It means in the given polynomial, if you substitute x is equal to 2, we get 0. Its value is 0. Similarly, if you substitute x is equal to 3 in the given polynomial, we get its value. Is 0. That is why we can say that here 2 and 3 are the zeros of the given polynomial. Okay, my children, understood these points? Right.